Assalamualaikum and hi everyone. So for this video, kita akan cover subtopic 4.5 metallic bond. And here are the learning outcome for this video. So at the end of this lesson, you should be able to explain the formation of metallic bond by using electron C model. And then relate the metallic bond to the following properties of metal such as malleability, ductility, electrical conductivity, and also thermal conductivity. Next, explain the factors that affect the strength of metallic bond and relate the strength of metallic bond and the change of boiling point of substances. Alright, so dalam chapter 3, okay, kita dah jumpa periodic table and here are parts yang melibatkan metal. Okay, so the one in green are all metallic elements. Okay, so physical properties of metal, ini semua kamu dah pernah belajar before this. It is lustrous ataupun bersifat shiny and malleable. Malleable means it can be hammered, okay, boleh diketuk, okay, and you can form a thin sheet or a thin layer of metal. And you can also mold it into different shapes. Kamu boleh temper the metal, okay, into different shapes without breaking it. And you can say metal it is ductile. So ini yang sifat ini yang kita gunakan dalam copper. Okay, sebab copper kita banyak gunakan copper dalam wiring. So maksudnya kita boleh jadikan dia sebagai wire, kita tarik and make it long, elongate tanpa putus. So that is also properties of metal, and it is also good conductors of heat and also electricity. Right, so metallic bond yang kita nak belajar ni, it can be defined as electrostatic force between positively charged of metal ion and the C. Okay, so perkataan dia C, ibarat lautan of the delocalized electron. So you can see the green one here is all the positively charged, and surrounded by the negatively charged here all the electron. Okay, so ini yang dinamakan sebagai electron C model. So if the question asks you to represent the electron C model, just draw, okay, let's say positively charged and surrounded by electron. So kalau specifically contoh metal sodium, let's say sodium metal, you just draw sodium and then surrounded by electron. Okay, so sodium. Okay, so something like this. So this is the representation of electron C model. Right, so in metallic bond, metal atoms can be imagined as array of positive ion immersed in the sea of delocalized valence electron. So you can see ini adalah dia punya representation lah, macam mana susunan of the positively charged and also the electron. These delocalized electron are not bound to individual atom, so it is free moving. Okay, and they can therefore serve to bind large numbers of metal atoms together. So you can see the electron, actually it is freely move around the positively charged ions. Okay, so in metallic bonding, the electron does not belong to any particular metal atom. So maksudnya, as we discussed just now, electron tu it is freely move, okay, dia akan move around dengan bebas. So it is itu yang menyebabkan metal mempunyai beberapa physical properties yang kita dah bincang tadi, such as dia boleh conduct electricity, it can be malleable, it is ductile. Okay, so in this case, if sufficient force, bila kita bagi tekanan yang tertentu to the metal, one layer of the atom can slide over one another without disrupting the metallic bond. So contoh, let's say you have Okay, ni satu layer, dua layer. So bila kita bagi force dekat metal, so it can be represent, okay, dia akan slide through and dia akan jadi one layer, okay, tanpa memutuskan ataupun without breaking it. Okay, so this means that metallic bond is flexible and also strong. Sebab tu kita boleh shape dia, kita boleh jadikan dia wire and so on. Okay, so that is why we said that metal, they are malleable. Okay, it can be hammered into shapes. Okay, you can change the shape and you can draw into wires. It is said to be ductile without breaking it. Alright, so as we discussed just now, elektron sifat dia bergerak dengan bebas. Dia tak terikat dengan specific atom. So, the delocalized electrons in metal, they are mobile and free to move away from one negative electrode to another positive electrode. So, let's say lah kita ada negative electrode and then this is the positive electrode. So, elektron dia boleh move around pergi ke positive electrode. So, that is why kita cakap elektron freely move. So, itu yang membuatkan metal can conduct electricity and can conduct heat. Okay. So, as we said just now, metal have high electrical conductivity because of this mobile electron. So it can also conduct, this mobile electron can also conduct heat by carrying kinetic energy from a hot part of the metal lattice to a cold one. So ini yang kita panggil sebagai thermal conductivity. Okay, kalau tadi kita discuss about electrical conductivity, and untuk this part, okay, kita mention tentang thermal conductivity. So, all of these two semuanya berkaitan dengan sifat elektron yang freely move around the mobile electrons. Okay? Alright, so next let's have a look at the strength of metallic bond. So, the strength of metallic bond, okay, so highlightkan dekat sini, strength of metallic bond, it depends on the number of valence electron. So relationship dia adalah the strength of metallic bond is directly proportional to the number of valence electron. So semakin banyak valence electron, number of valence electron, so the strength of metallic bond will also increase, and it is inversely proportional to atomic radius. So maksudnya kalau radius of the atom is small, so the strength of metallic bond increase. Okay, so ini dia punya relationship. So make sure you highlight this thing, strength of metallic bond directly proportional to the number of valence electron per atom. Okay, so the bonding will be weaker, let's say in sodium, because it only have one electron, one valence electron, compared to magnesium. Magnesium in group 2, so it has 2 valence electron, and for aluminium, okay, it will be stronger because it has 3 valence electron. Okay, so strength related to the number of valence electron per atom. Okay, so let's compare the effect of strength of metallic bond on melting and boiling point for metal. So the stronger the metallic bond in the metal lattice, the higher the melting and boiling point. So maksudnya kalau metallic bond tu strong, okay, stronger, means you need more energy to break that metallic bond. So that is why the result will be high in boiling point and also melting point. Okay, so sama juga konsep dia macam sebelum ni. Kenapa melting point dengan boiling point tu higher? Because you need more energy. Okay, kenapa kita need more energy? Because the forces of attraction ataupun the bond is strong. So in this case, kita discuss tentang strength of the metallic bond. Okay, so let's have a look into these few examples. So let's say you have these elements. Okay, ada sodium, magnesium, aluminium. So all these three adalah dalam period 3. Okay, and you can see the differences in the number of valence electron. And lithium, beryllium and boron, all of this in period 2. You can see lithium ada 1 valence electron, beryllium 2, boron 3. So let's have a look at the trend. So kita bahagi into few parts. Okay, so kita compare yang ini dahulu. Okay, so sodium, magnesium and aluminium, you can see melting point 98, 650, 660 increase kan. And boiling point 892, 1107, 2450 degree Celsius, so increase. So you can see the strength, okay, the higher the number of valence electron, okay, maksudnya the strength of the metallic bond increase, and the result will be melting point and also boiling point will also increase. Okay, alright, so for this part, lithium, beryllium and boron, okay, sama jugalah. So you can see here, lithium ada 1 valence electron, beryllium 2, boron 3. So you can see lithium melting point 180, beryllium 12, 1280 and boron 2300. Okay, so you can see the pattern, the trend is increase, and here also increase in melting point and also boiling point. So let's analyze into more detail. Okay, so kalau kamu tengok, let's have a look at this explanation. So, melting point and also boiling point increase from sodium to aluminium. This is because of increase in the strength of metallic bond. And the same trend is shown in period 2. So, ini tadi period 3. This is in period 2. Okay, same trend. Sebab kita nampak dekat sini, increase in the number of valence electron will also relate dengan increase in the strength of metallic bond. Okay, so refer back to the relationship. So in this case, aluminium has the highest number of valence electron. Kalau kita compare sodium, magnesium and aluminium, that is why we said that it has the strongest metallic bond. Therefore, we need more heat. Ingat, kalau strong, we need more heat to overcome the strong bond ataupun strong metallic bond. Therefore, it will result into highest melting point and boiling point compared to sodium and also magnesium. In elements for period 2, okay, so you can see elements in period 2 have higher boiling point and also melting point compared to period 3. So, why? Because elements in period 2 have smaller atomic radius. So, kalau kita tengok relationship tadi, dia punya strength of the metallic bond directly proportional to the number of valence electron, but inversely for the atomic radius. Okay, so you can see untuk these elements, since it is in period 2, maksudnya dia punya radius smaller compared to these 3 elements in period 3, maksudnya this one, this sodium, magnesium and also aluminium, radius dia lebih larger. Okay, so for elements in period 2, since they have smaller atomic radius, so the metallic bond is stronger in period for elements in period 2. That is why it need more heat to overcome the strong metallic bond. So kalau kamu nampak dekat sini, dia punya trend, okay, kamu nampak dia punya value lebih besar compared to elements in period 3. So we can conclude that when going down group, size increase, metallic bond will becomes weaker, okay, as increase in size. So that is why melting point and also boiling point of sodium is lower compared to lithium. So kalau kita ingat balik, group 1 metal, you have lithium and sodium. Okay, so as we go down the group, size, atomic size increase. So kita boleh nampak lah dia punya relationship between strength of the metallic bond and also radius macam mana in this case lah. Alright, so let's have a look at the factors affecting the strength of van der Waals forces. So kalau melting point and boiling point for group 1, okay, so kita tengok kat sini, all elements in group 1, they are reactive metal. So kita ada lithium, sodium, potassium, rubidium and cesium. So you can see as you go down group 1, okay, melting point generally decrease, and also boiling point you can see generally trend dia decrease. Okay, right, so melting point and also boiling point decreases down the group because as we go down the group, generally size of atom increases. Ingat balik ansatz. Okay, so this will cause the electron to be less attracted to the nucleus. So maksudnya radius dia semakin besar. So maksudnya jarak outermost electron tu dengan nucleus jadi semakin jauh. That is why the metallic bond will become weaker as we go down the group. Therefore, less energy is needed to overcome the weak attractive forces. So maksudnya you just need a little amount of energy to break the metallic bond. So that is why kalau going down the group, melting point and also boiling point will decrease as we go down group. Okay, now let's have a look at the trend for group 17. Okay, so ni lain sikit lah. So, kalau tadi kita tengok, as you go down group, size semakin besar. So, maksudnya melting point and also boiling point semakin decrease. Okay, semakin berkurang lah. You need less energy to overcome the bond. So, untuk this group 17, dia terbalik. So, you need, as you go down the group, fluorine, chlorine, bromine, iodine, you can see the melting point and also boiling point ni semakin besar. Okay, so why? Kita akan tengok lah after this dia punya explanation. So, untuk group 17, why the melting point and also boiling point increase? So, bila melting point and also boiling point increase ni, maksudnya mesti you need more energy. Need more energy to break the bond. Okay, so let's have a look at the explanation. So, untuk all halogen, they will exist as diatom. So, maksudnya dia akan jadi Br2, F2, Cl2, I2. So, the valence electron is in configuration of Ns2 and P5. So in this case, the valence electron, okay, is being shared with another. Contoh fluorine, dia akan share valence electron dengan another fluorine atom to form covalent bond in order to achieve noble gas configuration. So untuk group 17, as we go down the group, size will become bigger. Okay, atomic size will become bigger. So, bila atomic size become bigger, so macam contohnya, if you have I2, so between I2 dengan F2. So, as you go down the group, size of the atom dah besar. So, maksudnya, size of the molecule pun akan jadi semakin besar. That is why forces of attraction between molecule will increase. So apa-apa kita akan relate balik kepada forces of attraction between molecule. So that means we need more energy to overcome these forces. That is why melting point and also boiling point increases as we go down group 17. Okay, berbeza dengan yang tadi. Okay, so now let's have a look at the trend of melting point and also boiling point for elements across period 3. Okay, tadi kita dah compare group 1 and also group 17. Now kita nak tengok across period 3. So across period 3 kita ada elemen sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and also argon. So generally across period 3 you can see the trend untuk melting point dia akan jadi increase, sudden drop, sharp drop and then increase and then drop balik. Okay, so sama juga dengan boiling point, increase, sudden increase and then sudden drop. So dia akan generally drop. So why is this? Kita akan tengok the explanation. Okay, so melting point and boiling point across period 3 ni special sikit. There are few variation. So now kita tengok dulu between sodium to aluminium. Okay, so sodium to aluminium, sodium ada 1 valence electron, magnesium group 2 valence electron, aluminium ada 3 valence electron. Okay, so the metallic crystal have positive metal ions attracted by electrons in a cloud. So ini yang kita panggil sebagai metallic bond. So the strength of metallic bond tadi kita dah discuss is directly proportional to the number of valence electron. So semakin banyak number of valence electron, so the strength will also increase. Okay, so ini explanation untuk trend for sodium, magnesium, aluminium. Kenapa ada increase. Right, so next kita tengok kenapa dekat silicon ada special sikit. Okay, so this is because of the gigantic molecular structure of silicon. So silicon, it is made up of atoms that are tetrahedrally covalent bond to other S atom at the neighboring lattice site. So structure of silicon ni dia sangat besar, sangat bulky. This will result in crystal that essentially one gigantic molecule. Maksudnya structure itu sangat-sangatlah besar. So melting point and also boiling point of silicon will also be very high because of the strong attraction between the covalent bond. So this high energy, since the strong attraction, there are strong attraction, so maksudnya you need high energy juga untuk overcome the strong covalent bond ataupun to break the bond. That is why bila kita perlukan high energy, that means the melting point and also boiling point will also be very high, sangat-sangat tinggi. Right, so let's have a look for the elements from phosphorus to argon. So these are the mainly non-metal that exist as molecule. So kita ada phosphorus, dia akan exist sebagai P4, sulfur S8, Cl, Cl2 and argon dia sebagai monoatom. So all of this adalah non-metal. So the covalent bond between the atoms is very strong, but intermolecular forces such as the van der Waals forces is very weak. Okay, so intermolecular forces tu is between one molecule with another molecule. Okay, so kita refer balik kepada van der Waals forces. Okay, so since dia bukan metal, kita tak boleh cakap dia ada metallic bond. Metallic bond dia tak ada. So kita akan refer kepada IMF. So the van der Waals forces is proportional to the size. So maksudnya size besar, increase in size will increase in the van der Waals forces. Okay, the strength of van der Waals forces maksudnya akan ada increase in the boiling point and also melting point lah. Ini kita relate balik kepada sebelum ni kita dah belajar intermolecular forces, factors affecting the strength of melting point and also boiling point. So, molecular size of them, phosphorus sampailah argon ni, okay, adalah seperti berikut. So, argon is the smallest compared to Cl2, P4 and the largest adalah S8. Therefore, susunan melting point ataupun boiling point adalah seperti begini.